Hello and welcome back to another session of the Tip of the Month with Progeox. In this session, we'll go over a tool that's specifically designed to create wedges inside underground mines. As we know, wedges are a common problem in rock engineering and are formed by the intersection of discontinuities. These wedges can present a potential risk inside our mine, and it is best to gather the information that we took on site into our software so we can see where our risks are inside of our mine and we can assess them. Taking a better look inside our drawing, we can see that we have our drift, as well as some face maps and some discontinuities already in our drawing. So we go back to plan view, and to start creating our wedges, we will first need to create a set of discontinuities that will have to be a minimum number of 3 and will have to be intersecting. So to create our discontinuities, we can create them directly through this command, which is the draw custom polylines, and where we can draw a new set of discontinuities or assign them to already existing polylines. For this case, we'll create some new polylines and we'll set them around this area. So these polylines will represent the discontinuity that we are talking about and are involved in our wedge. So this would be a good set of discontinuities, and we will set these polylines at the elevation of our drift. So we can find that out with our ID command and setting our snaps. We check the top elevation of our drift and we can see that it's at 1203. So we go back to plan view and we set the elevation for these polylines at 1203. So now that we're all set, we can set the property of a discontinuity to all of these lines. So we go back to our command to draw custom polylines, and we go over to our assign option. And here we have a different set of discontinuities that we can assign to our polylines, like faults, shears, etc. So for this case, we'll use our fault number 2, and we just need to click on our polylines. And we hit enter. And they got assigned the property of the type of fault that we're going to be working with. So once that we have attributed the property of a fault, we can continue to give more annotations to our fault by inserting the structure. We just need to click on our fault, and it'll ask us for a name. In this case, we'll call it FLT1, and the location will be level 1200. And automatically it detects the elevation in which we're in. And here we'll add more information for the dip and the azimuth. So we just click on add and we select the direction for our dip. We have the distance from where it started our polyline, the dip angle, the azimuth in which our fault is pointing to, the projection distance, and our elevation. We also have the option to select the structure type. In this case, we'll work with fault, and the rock type, which we'll leave at MAG. So once we're done, we just click on OK and OK. So here we have our dip, which we left at 45 degrees, and our azimuth. So we can continue to do the same process for our other faults. We go back to our insert structure command, and we select our polyline. And again, we name it as FLT2. And the location will be level 1200, and the elevation is automatically set for us. So we go back to add, and we select our polyline again and the side for our structure. So we have the distance from which it started from our beginning polyline, our dip angle, which we'll change it to 55, and the azimuth, which is the one of our fault, the projection distance, and the elevation. And again, for the structure type, we'll leave it as fault and the same rock type. We click on OK and on OK. And for our last fault, we just do the same process. We click on our fault. The name will be FLT3. The location will be level 1200. And the line type, again, we'll leave it as fault 2. And we will add more information for our discontinuity. We click it and set the direction for the structure. And again, we leave everything as default for our distance to start. Our dip angle, we'll leave it at 45 again. And we have the azimuth, the projection distance, and as well as our elevation. The structure type will be fault, rock type will be MAG. So once we're all set, we just click on OK. And we have all the information necessary for our faults. Now we are ready to create our wedge. We go over to our create wedge command. We select it and we select the vertical projection height, which will leave it at 5 meters, as well the extend structure distance, which will leave it at 5 meters also. And we check our box to not keep the structure surfaces. So we click on OK and select our objects. We press enter and automatically it created our structures and our wedge. We can get a better view with conceptual. And we can even filter out our faults to get a better look at our wedge. We can create another layer called wedge and go back to 2D wireframe and select our wedge. We can send it to our wedge layer and erase our other structures for our faults. Go back to plan view and erase these structures. Once we erase them, we can take a better look into our wedge, and we can even calculate the information for it in this tool that we have called wedge data. We select our wedge and automatically it gives us the tonnage for our wedge, the height, the user that created it, and the date it was created on. So we just click on OK. We hope you found this tip useful and can apply it inside of your mine planning. And it is always a great option to maintain your security levels high inside your mine and protect your people as well as your equipment. If you have any questions or comments, please leave them down in the question section below and we'll gladly answer you. Thank you and have a great day.